Good evening, colleagues. I have with me a question today, which I want us to discuss together. This is about probability, and my main focus is I want us to look at how we can draw a tree diagram given a question on probability with a specific condition, as we can see from this question. I picked this question from a paper for 2017, if I'm not mistaken, but let's focus on the idea I want to communicate here, which is very, very cardinal. Mainly, students have been having challenges on drawing a tree diagram because of not understanding conditions of conditions given in a passage for a question to do with probability. So this question reads: a box of chalk contains 5 white, 4 blue, and 3 yellow pieces of chalk. A piece of chalk is selected at random from the box and not replaced. See, I have underlined the phrase "not replaced" for a purpose, because I want us to understand this condition, how it is used in a question to do with probability. And the passage continues to say, a second piece of chalk is then selected. Question A says, draw a tree diagram to show all the possible outcomes. So before we rush into drawing the tree diagram, it is very important for us to identify the groups of items that we have in either a box, as this question says, or a bag, or whatsoever term that they use. It's very, very important for us to identify the group of items that we have. So in this case, this question is talking about a box of chalk. So from this box of chalk, we can see that we had 5 white, 4 blue, and 3 yellow pieces of chalk. So you identify them and write them on as your information. Very, very important. So as you can see, I have 5 white pieces of chalk represented by the letter W, and these 5 were in total. These white pieces of chalk were in total 5. So you identify another group of pieces of chalk. As the sentence says, we had 4 blue, so we have blue pieces blue pieces of chalk, which were equal to 4, and we had in this box of chalk yellow pieces represented by the letter Y, and they were in total 3. So having identified these groups, this shows that for your tree diagram, as the question says in question A, for your tree diagram, this simply means that you are going to have 3 branches, because this is talking about a tree diagram. So you need to have 3 branches. The first branch represented by W for the 5 pieces of chalk. The second branch of the tree diagram will be represented by B, representing blue pieces of chalk. The third one will be represented by Y for the third branch in the tree diagram. So here is the way to go about this one. Remember the conditions that we have been given in this one. They are saying a piece of chalk is selected. The first piece of chalk was selected. So our tree diagram, first of all, in the first place, it will be like this. It's going to have forget about this. It's going to have the first branch, the second branch, and the third branch. So the first branch, we know, is representing the white pieces of chalk. You indicate W there. The second branch representing the blue pieces, you indicate blue there, and the third one is representing Y for the yellow pieces of chalk. So this all tree diagram, the first branch represents the first selection. The first selection. So in the first selection, we need to be mindful of the fact, or rather the formula for probability. Probability P of any event, probability P of any event to take place is defined. For example, let me pick the event W, the event of picking W. This is going to interpret as the favorable outcome, meaning if the piece of chalk that was picked, the first piece of chalk that was picked was white, so the favorable outcome is supposed to reflect the total number of white chalk that was in this box. So the first piece of chalk to be picked in this first selection, if we assume that it was the white piece that was selected, we are supposed to reflect in our the probability of a white chalk to be picked is the favorable outcome. So the favorable is what I'm trying to say. It has to reflect the number of 5 pieces of chalk that were in the box. So we are saying we have 5 out of, we know what's supposed to be at the bottom here is the total possible outcome that were in the box. So for the total possible outcome, which is supposed to be here, you simply add this 5 plus this 4 plus this 3 to give us the total possible outcome of 12. So for the first selection, we assume that it was the white piece of chalk that was selected. So the probability of picking a white will be put here as 5 out of 12. You put it there on a tree diagram, the first branch, of course. Then we assume that the branch, the piece of chalk that was picked, suppose it was blue. So the probability of picking blue, again, we write it in this format. We have the first piece to be picked, we assume it is a blue piece. We look at the favorable outcome over the total possible. So the favorable for blue, it will mean that we have the 4 blue pieces in the box. So the favorable outcome is simply supposed to be 4 out of the total, which is the total possible outcome. As we are where I said we are supposed to add all the totals for the colors of chalk, which is giving us 12. So if the first piece to be picked was blue in the first selection, we are supposed to assume that this branch is supposed to have 4 out of 12, as we can see from there. So then also this applies for the yellow. If the probability of picking the yellow in the first selection will be something that will look like this. So this will be again, the favorable outcome for yellow is 3 out of the total 12. So this is the first selection, remember. So in our first selection we have 3 out of 12 for yellow. So now we should also consider in mind that we are done with the first selection. So we go to the second selection. I want us to put this here. We go to the second selection. We indicate the second selection there. So in our second selection, these branches now, they are going to, each branch is going to give birth to 3 more branches. So the first branch for white is going to be represented by this. We have white here. Then we have blue there. Sorry, this paper is moving. We have blue there, and we have yellow there. This is in the second selection. And then this branch here, Sorry, I've put the distance here. I want us to see, to have enough space here. So this branch here continues. So now we come to the second selection. For if the second selection, each branch I said is supposed to give birth to 3. So here again we say we assume there is we assume it is blue. So this will represent white. Again, the middle one always representing blue, and the third one representing yellow. So again, this yellow also gives birth to 3. So we have this branch here representing white, and then this one here representing blue, and then this one here representing yellow. So just like that. So in our tree diagram, we look at this. So at the end of all these, we should have the product or the result of all these probabilities, which will come here at the end of this broken line here. So now in the second selection, let's go back to putting the probabilities for each branch here. We assume this is a second selection for all these branches now. Now we will be assuming that the first branch here, since the first branch here is representing white, so we are assuming here that it was the white chalk that was picked the second time. It was the white chalk that was picked the second time. So in our assumption, if it was the white chalk, remember in the box we had 5 white chalk. Now that in the first selection, 1 white chalk was picked in the first selection. This is the selection for white. Here we are assuming that it is a white. Here we are assuming that the second time it was a white that was picked. Now, when we look at from the box, we only have the total number of 5 white chalk. If the first selection that of a piece of chalk that was taken was for white, we assume that the favorable outcome for white here has to reduce, because the first one which was picked here, we assume it was a white. So the total favorable outcome here has to reduce to 4. Now, what will be the total possible outcome? The total possible outcome then does not remain the same. Why am I saying so? Because of the condition we are seeing here, which is saying a piece of chalk is selected at random from the box and not replaced, because when I pick a piece of chalk, it means I will use it, and when I use a piece of chalk, it is going to finish. I can't replace it the same way as it was. So if in the total we had 12 and 1 was picked that was yellow and it has been used, meaning that if the white chalk reduces, the total also has to reduce to 11, because there were 12. Therefore, the total now will reduce to 11. So that is the case. Now, in the second selection, if we are making assumption that it is a white chalk that was selected, meaning that the remaining, these others will maintain their favorable outcome will remain the same, but the total possible outcome down there will reduce because it has reduced already. So we are saying for blue remains 4 over the total possible outcome, which is now has reduced to 11 here, So the yellow also will remain the same. We had 3 yellow, and the total possible outcome reduces to 11, as you can see there. Now, the whole instance is that when we are putting these fractions you are seeing around here, when we add all these 3, they should give us 1. When you add all these fractions, they should give you 1 as their result. If the fractions give you more than 1, we know that the probability ranges only from 0 to 1. So we can't have, it is between 0 and 1. That is the variation of a probability. We can't have more than 1. If all the probability conditions they give us above 1, then there is something wrong with our probabilities in all these branches here. So we go to the next one. Now this next one, the next branches here, they are representing the blue from the original. They are representing the blue. So in this branch here, we are assuming that the second piece of chalk in the second selection, the second piece of chalk that was selected for the second time, this time it is blue. We assume it is blue. Okay, so now if it is blue that was selected, remember from the box we only had 4 blue pieces of chalk, and if the first one that was selected was blue, the blue favorable will not remain as 4. Instead it will reduce to 3, whereas the total reduces to 4, and therefore these others will remain, their favorable outcome will remain the same. So you maintain this as 5 over 11, and the yellow maintains, because in this probability, in this branch, we are assuming that it is blue that was selected. So here we say that the rest remains the same. So we have 3 over 11, because the total possible outcome was reduced. As you can see, we have 11 here, we have 11 there, we have 11 there. Why reducing? Because something has been taken and it has been used. There will never be a replacement. It's like you have 5 pieces of 5 sweets in your pocket, and then these sweets, others are blue, others are green. Then you pick at random a piece of a piece of sweet from the pocket and you eat it. How do you expect the total to remain? The total remains as 4. So when they ask you to say how many pieces of chalk that is left in the box, if one was picked and it is eaten, meaning that the total reduces to 4. So this is an example that is applying also on these probabilities. So see, in the third branches here, the third set of branches here, this one now will represent the yellow, because we only have three classes of, or 3 groups of chalk, or 3 colors of chalk, so of which the third is yellow. So in this third set of branches, we are assuming that what is picked the second time is a yellow piece of chalk. So now, since we had the 3 pieces of chalk initially in the box, and the first one was this one that was picked, so from the 3 pieces of yellow pieces of chalk, you don't remain with the 3 again here. The favorable outcome reduces to 2, whereas the total has already reduced, because one that was picked was a yellow the first time, and from 12 we remain with 11. So that is the implication here. So it means if the yellow is the one that was picked the second time, these other 2, they remain the same from the original. You just pick them from here. So you transfer this fraction, the favorable outcome, to here, 4 over the favorable total possible outcome, 11. Again here you say you have for white, you maintain the same as 5 over 11. So all these fractions, all these probabilities, when you add them together, they should give you 1. If you want, we can prove that to show that these our probabilities are correct. If they don't give us 1, then something is wrong. I want us to look at this this concept here. This one is an example that I gave. So we close that one. But let's look at how do we prove that my probability questions are correct. So let me do it from here. You see, we have to add all the fractions. 5 out of 11 plus 4 out of 11 plus 2 out of 11. So to add these, to verify or prove that our probability fractions are correct, when we add them, they have to give us 1. So we look for the common denominator, which is 11, of course, and then we put the bar there. We shall begin to say 11 into this one, which is 1. 1 times 5 is 5, plus again 11 into 11, it is 1. 1 times the 4, it is 4, plus 11 into 11, it is again 1. 1 times the 2 there is 2. So this is giving us, on top we have 5 plus 4, which is 9, plus 2 is 11 on top, and at the bottom 11. So this is simply 11 divided by 11, and it's 1. So since we've gotten 1, it means our probability fractions here, they are correct. So that is the procedure on the tree diagram. The spacing here shouldn't be too much. As you can see, these branches were supposed to come a little bit closer to this one, but I think I was using a paper and it was moving, so it led me to that far. So that is about a tree diagram. Now, for the sake of the next question, to be easy, which says find the probability of selecting pieces of chalk of the same color. Now, for this question to be easy for us, we have to find the product of the branches of these. So to find the results, we have to find the results of. Now, in finding the results of these probabilities, we are multiplying this one, each branch against these branches. We multiply along the branches. For white, just like that, and then for yellow and white. So these branches will multiply just like that. This white and white, as you can see. So we have white and white. So we have W times W for this branch and that one. Then we have this branch here times B. So let's complete the multiplication with white. This white times W. So we are saying this one times W. W times B, like that. Again, W times Y here, like that. So we come to this branch which gave birth to this. Again, this branch we multiply with all these this set of branches. So we shall say B times W, B times W, again B times B, B times B. So branches multiply along. So this B times that. Again, this B times yellow. So B times Y. So these will be the results. And you see that it will be very easy for us to get the results when we do that from that far end there. So now we come to this, the third branch which gave birth to the set of branches down there. So we shall say yellow times W. Then we're saying yellow times B, and then yellow times yellow. Okay, like that. So this is how we obtain the results. So I repeat, this branch will have to multiply all the branches to which it gave birth. So we said W times W, again W times B, W times Y, just like that. So this is as a result of multiplying this one and these branches here. So we have this and that. And then B again multiplies this, B times that, this is the result. B times Y, this is the result. So this one also gave birth to these branches. So this one times that. This is y times w, y times b, y times b, y times y times y. So now, meaning what this implies to say is that or along each branch there's a probability, there's a fraction. So this fraction is a fraction for this first w. So we've got 5 times 12, 5 over 12 times this w here. This w here is for the second selection. So we've got 4 out of 11. Like that. As you can see, I'm sure you're able to see. Then here again we've got w, which is for this one. This w is the first w, which is giving us 5 out of 12 times b. This b is for the second selection, which was maintaining as 4 out of 11, like that. And then we continue just like that. Now to quickly answer the question that they are asking us, what we need to do is this. The question says, find the probability of selecting pieces of chalk of the same color. So in my view, I will look at I'm going to look at the following. A probability of the same color will be this. The probability of the same color will have w times w, okay, w times w, or when we check we have blue times blue. These are of the same color. These are of the same color, blue and blue. So blue times blue, or the other selection of the same color is y times y, yellow times yellow, which is y times y in that selection. So now the language of probability here is that see what I've come up with. I have white and white, or blue and blue. This is the selection of the same color, or yellow and yellow. So now the probability, in probability, when we use the word or, we mean plus. So this probability of picking white and white, plus the probability of picking blue and blue, plus the probability of picking yellow and yellow. So we just pick the fractions that we've gotten from here, which is for white and white, giving us this one. Sorry, the fractions that we multiplied here, they were not, the space was too small, but I'm sure we are going to pick them from here. So for white and white, we got this one here. So now this one is going to give us the first fraction 12 times the second fraction 4 out of 11. So we have 5 out of 12 times 4 out of 11 here in this selection. The word or means plus. So we have for blue and blue, let's go to the branches that gave birth to blue and blue. We have, this is blue and that is blue. So hence we had this blue times blue. So the first fraction for blue is this one, which is 4 out of 12. So we have 4 out of 12 times, this is blue and blue. Blue means blue times blue. So we have another blue here, which was this one. So this blue, the fraction is 3 out of 11. Or means plus there, as you can see there. So yellow and yellow, again we come to this one, which is yellow and yellow. So check, the first yellow is 3 out of 12, the second one is 2 out of 11. So we have the first yellow, which is this one, As you can see, the first yellow, which is this one, is supposed to be 3 out of 12 times the second yellow, which is 2 out of 11. So we have 2 out of 11 here. So these results, we had them together. So we are saying this times this is so we have to reduce the fractions. If we want, we can reduce the fractions. We have 4 here, we have 12 here, and this 4 can go into 12. We can reduce the fraction. So we have 1 here. 4 into 4 is 1, and 4 into 12 is 3. We have that fraction reducing to that. Equally here, we can reduce the fraction. We have this 3 can go into 12 one time. This 3 into 3 is 1. Then 3 into 12 is 4. We have 4 there. Then coming to this one again, we have this 2 can go into 12, so we reduce by by 2. So 2 there is 1, 2 there is 6. So since we have reduced the fractions, we can multiply them. This times 1 is 5 over 3 times 11 is 33, plus this 4 times 1, we have 4 over 4 times 11, 44, plus this 3 times 1 is 3 over 6 times 11, which is 6. So we had these fractions together. So you have to say the probability of picking the pieces of chalk of the same color is equal to probability of picking blue plus the probability of picking, white plus the probability of picking blue plus the probability of picking yellow. So the actual sense out of this is that the probability of picking a piece of chalk of the same color is, we have the probability of picking white, or the probability of picking blue, or the probability of picking yellow. So these are the ones that we come up with. So now we simplify all these by multiplying this and that, but we have to look at for the numbers that can reduce. If the numbers can reduce to this, like you saw me reducing, this number can go into that one, reduces to this one. So for us to find the final one, we can as well reduce if we have fractions that can reduce further. Okay, so that we can have something that will be easy. I have 4 here. Okay, I have 4 here, and this 4 can go into 44. This 5 can't go into 33. So this 4 there is 1, 4 there is 11. And then this 3 also can reduce. This fraction can reduce. I can say 3 there is 1, and 3 there is 22. Okay, 22. So we look for the number. Now we have the fractions such as 5 over 33 plus 1 over 11 plus 1 over 22. Okay, so now we look for the number. If we want, we can add these separately. We add these first, then we add this one. If we can't find the commonest denominator, we can say, okay, let us say which one is the highest common factor, the lowest common factor of 33, 11, and 22. The number through which 33 can go, 11 can go, and 22 can go. I guess it is 66. So we say 66 is the common. We believe that 11 can go into 66. How many times? 6 times. We believe that 22 can go into 66. How many times? 3 times. So this one also can go there. So we say 66. Everything is, this is our common denominator. Then we'll be saying this 33 into 66. How many times does it go there? It goes there 2 times. So 2 times 5, it's giving us 10. We write 10 there. Then we bring this plus here. Then we say 11 into 66. It goes there 6 times. 6 times this one here is 6. Again, we bring this plus here. Then we say 22 into 66. It goes there 3 times. So 3 times 1, it is 3. So we add what is on top here, and our probability will become something like this. 10 plus this plus 3 is giving us 19 over 66. So this looks to be our final answer, because we don't have a number that can go into 19 and 66 without giving us a remainder. So the probability of picking the pieces of chalk of the same color is 19 out of 66. So this ends here. Thank you so much for attending to my class today. God bless you, and we are looking forward for more critical questions that will be handled exactly the same way we've handled this one. So you can have ample time to go through this question, find more questions to do with probability, and then we can you can seek for help either from my YouTube, because I'll be doing probability, I'll be doing set theories, I'll be doing these other challenging questions that mathematics comes along with. Thank you so much.